Before we get into this video, I wanted to clearly point out the purpose of this, and that is to replace and upgrade the bronze bushings that are used by the rear spindle in my lathes headstock. The front spindle uses regular tapered roller bearings, but as you can see, there is some play in that rear spindle that I believe is contributing to some headstock noise that I've been hearing. So I want to replace the bronze bushings with bearings and see if that makes any difference. I'm not sure whether or not it will, but it's worth a shot. So each side of the back spindle has a bronze bushing that we are going to replace, but the first thing we need to do on the left hand side is replace the flange that's behind the pulley here to fit a 24mm bearing. So I decided to go with this 2-inch piece of steel because that will allow us to make an almost one-for-one identical copy of the flange that's currently on the lathe. These are the first couple passes that we're going to make on this piece. All we're trying to do here is set the outside diameter to 48mm. Since it was 2-inch stock steel, it came about almost 51mm, so we're not taking off much. So we ended up just getting a little bit above 48mm, which is fine. This is not a critical dimension. This is just the outermost part of the flange that will have the 3 holes that bolt to the side of the headstock. So next up, we're going to start doing the more serious passes and working on this inside diameter of 30mm. Here we're starting the passes to get the piece down to 30mm. This 30mm section, which is it's 30mm diameter and then 13mm in length, this is what's actually going to stick into the lathe. So the 30mm has to be about as accurate as we can get it to ensure a tight fit in the lathe in the headstock. And then here you'll see my dial indicator just letting me know when I've hit that 13mm mark, so I don't go any further. After a couple more minutes of machining, you can now clearly see the step that we were going for. So we have the 48mm outside diameter and then the 30mm diameter here. Now I'm going to grab a pair of calipers and check to see how close we were. We ended up coming in just a hair under 30mm, which actually worked out perfectly. It was a very snug fit, so 30mm on the dot might have been a little bit too big, but this worked out, so I was good here. And then checking the depth of this, we wanted it 13mm, and we ended up coming almost right on the dot, 13.07. So happy with that. And next step we're going to move on to is drilling the holes for the bearings. Here we're drilling through the workpiece. The first hole I wanted to drill needed to be 15mm in diameter all the way through the workpiece, which will allow the rear spindle to pass through. So I believe I started with 1/8 inch drill bit, worked my way up to a 1/2 inch drill bit, and then had to switch over to the boring bar because 1/2 inch drill bit is smaller than 15mm. So switch to the boring bar, finished a couple passes, and then kept working with the boring bar to start boring out a cavity for where the bearings are going to sit. One other important thing to note here is that during the last couple passes with the boring bar, I did have the lathe carriage moving as slow as it could by using the fine feed knob on the side. So I had that pulled out, and that just allowed for a much smoother finish for the spindle to go through. We were aiming for an inside diameter here of about 15 millimeters or a tad over, just to allow enough clearance for the spindle to pass through. So we ended up coming in at 15, I think 0.05 was the final reading that I got. So I was happy with it. It works perfectly, so we're good there. The next step is going to be where my finger's pointing. We're going to bore this section out, just this stretch of 13 millimeters to 24 millimeters inside diameter, and that's where the bearings are going to seat. Here's how the part is looking after a little bit of time boring it out. You can see the through hole and then the cavity for the ball bearings. The next step I need to do is to remove some material from the other side of the flange. Here's a shot of what I was trying to remove. It wasn't my favorite method using a parting tool like this, but it worked. I was trying to avoid flipping the part in the chuck, but I ran into some clearance issues with the part off tool holder, so I ended up having to do that anyways. Here's the part reversed in the chuck. What we were trying to do here was take the outside diameter of this lip down to right around 28 millimeters. This also wasn't a super crucial dimension, just needed enough for the pulley gear to clear. So we ended up just a little bit over 28 millimeters, and it works fine. Here I am trying to reduce the thickness of this outermost part of the flange. This is where the holes will be drilled through for the bolts so that it can be bolted onto the side of the headstock. We wanted this part to be about 2.5 millimeters thick, and we were pretty close with our measurement. The final step in this process was taking this lip, this outermost lip, down to 3.5 millimeters. So we're at about 6.5. So we needed to take 3 millimeters off of it. So I'm gonna skip ahead in the video, but I just faced this down until we're right around 3.5. I cut out a couple minutes of facing and checking measurements, but this is the last and final pass on this part. So I was trying to get this to a depth or a thickness, this little wall of about 3.5 millimeters or less. This was just to allow the pulley gear enough clearance. So if it's less than 3.5 millimeters, we're fine. If it's over, it was no good. So we ended up coming in at 3.4, so I was good with it. With all the lathe operations now complete, I was able to remove the stock flange and bushing to do a one-to-one comparison, check my work, and I was really happy with the results. Here I'm demonstrating why I needed to make a new flange, is because the bearings I wanted to use don't fit, and I could have bored this one out. It probably would have been easier, but I did not want to risk messing it up, and then I wouldn't be able to reuse the bronze bushing that came with it, so it would have made the lathe inoperable, so until I found another one. So didn't want to do that, so I just decided to make the new one. Really the last step now is transferring over the hole pattern so that I can drill the 3 holes that are necessary to bolt this to the headstock. Shouldn't be too hard of an operation. One thing you might notice, a big difference between the 2 flanges, is the black one has a groove cut out and a hole drilled in it for oil, which I did not do on mine because I am using sealed ball bearings, so I should not need to drill a hole in it. If I do, I can not a big deal, but for the time being, I'm leaving it as is. Before I drilled the final 3 holes, I decided to do a quick test fit just to make sure it fit in the side of the headstock, and it did. So it cleared the pulley shaft, which is great, and then it has a nice snug fit. It's not too tight, it's not too loose. The lathe is still able to spin freely. There's no bearings in it right now, but it is able to spin as it should, so very happy with it. I did one last test fit without the bearings installed to make sure that the whole pattern aligned and that we had clearance on everything, including the pulley gear. I'm very happy with how this turned out, so stay tuned till the next video where I will be installing this and testing it out. Thanks, guys.